So question 6, we are given a wire of length 1.5 meter and diameter 0.25 millimeter extend by 1.5 millimeter when a load of 120 Newton is placed on the wire. So class, since the question gives us the diameter of the wire, so we understood that our wire is a round wire. So the diameter of the wire is 0.25 millimeter. Change to meter, it will be times 10 power of negative 3 meter. So from the diameter, we can calculate the radius of the wire, and then we might calculate the cross-sectional area of the wire. Okay, whereby the cross-sectional area of the wire can be calculated by taking pi multiplied with radius squared. Okay, so this wire have an initial length of 1.5 meter, and then we find out that this wire will be extended by, it will be elongate, extend by a value of 1.5 millimeter times 10 negative 3 meter. So when we place a load of, when we apply a load or a force of 120 Newton. So question A, we would like to calculate the Young modulus Y of the wire. So if we refer to the equations that we have for this topic, so the Young modulus can be calculated by taking the stress divided by strain. So we write it down, Young modulus is stress over strain. And then how we are going to calculate the stress? The stress will be force divided by area. So I put it in force divided by area. The strain is referred to the elongation divided by the initial length. So we have delta L over L naught. So I rearrange the equation. I'm going to have force multiplied original length or the initial length divided by the cross-sectional area multiplied with the elongation or the extension delta L. So in order to solve this question, to calculate the Young modulus, I need to put in the value of the force, 120 Newton. The initial length is 1.5. The elongations or the extension of the wire is 1.5 to the power of negative 3 meter. Anyhow, the cross-sectional area of the wire is not given. So we need to calculate the area first. So I calculate the area of the wire. So area is given by pi r squared. So I put in the value pi. The radius of the wire will be the diameter divided by 2. So I'm going to have 0.25 to the power of negative 3. 0.25 to the power of negative 3 divided by 2. So I'm going to have 1.25 to the power of negative 4, my radius. 1.25 to the power of negative 4 for the radius of the wire. Then I do the calculations. You may pause the video to do the calculations for the cross-sectional area. So the cross-sectional area of the wire will be 4.91 to the power of negative 8 meters squared. Okay, now I put it in here to calculate the Young modulus. So the Young modulus will be the force 120 multiplied the original length or the initial length of the wire is 1.5. So the cross-sectional area 4.91 to the power of negative 8, and the extension of the wire is 1.5 millimeter times 10 negative 3 meter. So again, you can pause the video to do the calculation. So we will get the Young modulus should be 2.44 to the power of 12. The unit for Young modulus will be Pascal. Then we solve question A. Then we move on to question B. Question B, we want to calculate what will be the extension, the delta L, when a load of 85 Newton produced. So if now I change the force to 85 Newton, I want to calculate what will be the extension, the delta L that produced. So in order to calculate this question, because we are still using the same wire, since we are still using the same wire, so we are going to have the same value of Young modulus and also the cross-sectional area. I repeat, since the wire is the same, so we are going to have the same value for Young modulus and also the cross-sectional area for the wire. So again, I'm using this equation. So for question B, we are still using the same equation. Young modulus is force, original length or the initial length, divided by cross-sectional area, multiply extension, delta L. So I rearrange the equation because I want to calculate delta L. So delta L will be F L naught over area multiplied Young modulus. So now the force is 85 Newton, the initial length of the wire is 1.5 over the cross-sectional area is 4.91 to the power of -8. For the value of Young modulus, we can refer to the answer in question A. So we have 2.44 to the power of 12. So again, you may pause the video to do the calculation. So if you calculate correctly, you should get the extension of the wire should be 1.08 to the power of -3 meter. Okay, so we solve question B, then question C. What is the strain? What is the value of strain of the wire with a load of 85 Newton? So we want to find the strain of the wire when the force is 85 Newton. So from question B, we already get the extension of the wire when we place a load of 85 Newton. So now we want to find for the strain. So if we refer to the equation, we can calculate the strain by taking the elongation or the extension of the wire divided by its initial length. So we have strain is the extension of the wire divided by the original length or the initial length of the wire. So the extension already calculated in question B is 1.08 to the power of -3. The initial length of the wire is 1.5. So pause the video and do your calculations. So you should get 7.21 to the power of -4. So boys and girls, there will be no unit for strain because the extension of the wire, the unit is in meter. The initial length of the wire, the unit is in meter. So meter and meter will be cancelled out. So for the strain, we doesn't have any unit. Okay, I repeat, for strain, we are not going to have any units.